This video is about completing the square. Completing the square means filling in the right c value to create a perfect square trinomial. So you're starting out with x squared plus 8x plus c, because you're asked to fill in that c to make this a perfect square trinomial. So that's what it means to complete the square. So the best method to do it is to know that it's going to be half of 8, which is 4, and then you're going to square that value and get 16. That's how you're going to always figure out what the c value is. To write that formulaically, it's going to be b, the b value, which here is 8, divided by 2, and that whole quantity squared, to help you figure out what c should be in order to make this a perfect square trinomial. So we fill this in. We've got 8 divided by 2 to the second power, 4 squared, which is 16. Now what you're going to be asked to do is fill in the c value. So you're going to rewrite your trinomial x squared plus 8x plus 16. And then to show that this is now a perfect square trinomial, write it in factor form. If you were to factor this, you should recognize that it's going to be x plus 4, x plus 4. That's why you chose the 16, to make it a perfect square trinomial. And then we can write that as x plus 4 quantity squared. When it's an odd number for b, it's only slightly more complicated, but the process is still the same. It is still b over 2 squared, which here is negative 7 over 2 squared. And then you simplify it as much as you can. Negative 7 times negative 7 is 49. 2 times 2 is 4. I can't reduce that or simplify that fraction at all, so I'm going to leave that as my c value. The trinomial would be x squared minus 7x plus 49 over 4. And then to write that in factored form, it might seem a little more complicated, but in fact, what goes in these parentheses is always this value. It's the value that you used to get 49 over 4 to begin with. It's going to be minus 7 over 2 and minus 7 over 2. 4x minus 7 over 2 squared. The reason we use this is because completing the square can be used to solve quadratic equations. So we've got this quadratic equation here. We're not going to be able to factor this. Nothing multiplies to make 1 that adds up to negative 10. We're not going to be able to use square roots to solve this because we have an x squared term and we have an x term, and it's not a perfect square trinomial. If we can make it a perfect square trinomial, then we'll be able to use the square roots to solve it. So that's what we're going to try to do here. Make it a perfect square trinomial. The 1 is not helpful to us. We're going to start by moving that positive 1 to the other side and fill in our own c value there. So when I move 1 to the other side, it becomes negative 1. And I want to fill in my own c value to make that a perfect square trinomial. Because we have an equation now, anything you add to the left, you also have to add to the right. So I show this plus c in the first step on both sides, so I don't forget that when I add it to the left, I'm going to have to add it to the right as well. To figure out what c is, we use half of b squared, which here is negative 5 to the second power, which is 25. So now I know what my c value is. It's going to be x squared minus 10x plus 25. And remember to add the 25 to the other side as well. You can factor the left side of this equation to be x minus 5, x minus 5. Don't need that squared yet. Put it in the next step. And negative 1 plus 25 is 24. Simplifying the right side of the equation as well. We can write this as x minus 5 to the second power equals 24. And now we've given ourselves a version of the same exact equation that we can solve with square roots. I'm going to pause here and mention that if I was to subtract the 24, in fact, I'll switch colors to show this over here. If I was to subtract the 24 at this step and move it back to the side where the x is, what you're looking at when it's written in that order is vertex form. I know you've learned vertex form before. Vertex form is the form x minus h to the second power plus k, right, equals y, where h and k are your vertex. So if you're ever asked to find the vertex, using this completing the square method is a great way to convert it to vertex form and see what your vertex is. So let's go back to the original problem over here, the blue equation, and we're going to solve it. So we've got squared on both sides. So we can take the positive and negative square root, leaving us with x minus 5. In fact, we can drop the parentheses. We don't need those anymore. X minus 5. Squared goes away. The square root of 24, we can simplify that because 24 breaks into 4 and 6. We know that 4 has a square root of 2. So 2 root 6. And then we can add 5 to the other side, leaving us with x equals 5 plus or minus 2 root 6. So we took an equation that we couldn't solve using square roots and then used completing the square so that we could use square roots to solve it. You must have a coefficient of 1 in order to use completing the square. So in this example, we're starting out with a coefficient of 3 in front of our x squared, and that's not going to work if we try to start completing the square at this step. Wouldn't work. So the first thing we need to do is get this to be a 1 by dividing by 3. Now when you divide by 3, you're going to divide everything in the equation by 3. Keep it balanced. I purposely picked numbers here that are all divisible by 3 to make this a little easier on us. Plus 50 equals 0. And now what we're looking at is a trinomial that is not a perfect square. We want it to be a perfect square so that we can use our square root method. So we're going to start by moving the 50 to the other side, filling in our own c value. Remember, to determine c, you're going to use half of b squared, which here would be negative 12 over 2 squared, which is 6, negative 6 to the second power, which is 36. That tells us what our c value is. Positive 36. Don't forget to add it to the other side as well. Factoring this side gives us x minus 6 and x minus 6 again, so I can write it as x minus 6 to the second power. Negative 50 plus 36 is going to give us a negative 14. And now I can use square roots to solve. Take the positive or negative square root of both sides. This side ends up being x minus 6. Because this side has a negative underneath the square root, we're going to get a complex number, or an imaginary number on this side. There's no way I can simplify the square root of 14. There's no perfect squares that go into it. So all I'm going to do is pull out that negative and make it an I in front. So plus or minus I. Keep the square root of 14 as it is. And then we need to move the 6 to the other side. So positive 6 plus or minus I square root 14. And that's our complex number solutions to this quadratic. And that is all.